Okay, now in this one, we're joining two amino acids together. Now, the groups we're kind of interested in these ones and these ones, although we could just as easily have this attaching over here to hat. So there would be two possibilities. But just for ease, I'm going to join the two ones here together. And obviously that's going to result in a amide link, which I'll draw initially here. And then I'm really just copying the rest down. So on this side, I've got the H and the CH3, and then the NH2 on that side. And then once again, I'm just coming back on this side to draw in the rest of it. And that's a dipeptide. Now, notice this doesn't carry on because it's really just these two joining them together, hence the term di. Now, the type of reaction that joins together is a condensation reaction. Now, at this stage, this isn't a polymer. If it was joined together to make many repeating units, it would be, such as a protein. So it's a condensation reaction. You should describe it, which is when two molecules, such as the amino acids, join together, and they join together with an amide link, and that with the elimination of a small molecule. Okay, and that small molecule in this case is H2O. Now, if this was a polymer, I would talk about how that happened, that joining together happened with many repeating units to make a long chain. Now, diagrams won't always be labelled like this. This is distillation, where this kind of where these reactants get heated. They'll go up into here, and there'll be water going in here and water coming, or water going in here usually, actually, and water coming out there. And that's to cool it, and this will basically cause the gas that goes in here to cool and become a liquid. This is used for separation, so the difference in boiling points to separate out a product from other chemicals in there is how that is used, whereas reflux is really just heating this, and the volatile chemicals in here, which easily turn into a gas, will tend to go up into here, but they get cooled and will come back down and condense back into a liquid, so you can keep on heating it. So this is all about rate of reaction, and that's about basically maximizing the yield, which is the amount that you get. So anyway, in terms of this question, what's going on with it? We're using ethanol, and we're reacting it with propanoic acid to make an ester. So got to outline the procedure, the product that forms, draw the reactants and products. So we'll start with that. So with this, we've got CH. I'll draw these out here, so that's not much of a C, but anyway. Okay, having drawn this out, that's ethanol, and this is propanoic acid, and now you use concentrated sulfuric acid. It's kind of important that you know how that's used, and that's to remove the water, so it's a dehydrating agent, but it's a catalyst, and it forms the ester here, so that's the ester link, and of course it'll be water that gets formed as well. So that's the product form, that's the reagent used in it, and it's a terrible diagram there, but anyway. And how does each procedure be used to ensure you get the product there? Now, initially when you're reacting this together and you want to ensure you get maximum yield, you're going to basically be doing reflux. So you're going to want to heat this for an extended time without any losing it. So you'll talk about that. Okay, I've just really written this out, but the reflux bit is really all just about increasing the rate of reaction. And the fact that these are volatile just means they're they easily turn into a gas. And so when you heat them, you want them to condense back in. So you're using the condenser column, which cools the the surrounding glass walls, so they'll form back into a liquid. And the key here is it increases the rate of reaction and ensures you get maximum yield. So that's reflux. Then once you've done that, to try and ensure that you get kind of maximum reaction, you're going to distill it. And this is really for use separating the ester from anything else. And what they often talk about is getting a pure sample or a pure product, or whatever the case may be, depending on the experiment. And alcohols and acids in this case do have a higher boiling point. The ester itself will have a lower boiling point. So at a lower temperature, it will turn into a gas first and be condensed back into a liquid. So it's a means of separation, again, to try and get maximum yield. Now the sodium carbonate here is just an add-on that I put in because that's often asked about. And if you're using concentrated acid like this in the reaction, you need to neutralize that. So if you add liquid sodium carbonate to this, it basically will, this is to neutralize excess acid. And of course it will react with, this acid over here as well, but it's to neutralize any excess acid. And you can tell that when it basically stops bubbling. Now, one other thing that is often done before you go through distillation is you may add something like sodium sulfite or sulfite of any kind, and that's basically the anhydrous. And if you see that, it's really just to remove water. Now this question didn't ask about it, but it's a common chemical that's used in this process because you just want the organic compound. You don't want any extra water in there. You'll have tried to separate that out when you add, for instance, the sodium carbonate. So there's quite a bit of aqueous, or quite a bit of water in there. So you'll try to use the separating funnel to separate it, but there may still be some water there. So if you add this, that would remove it. Anyway, that should be an easy E on that one. Just a side note, the other reactions that tend to get asked on this is oxidation to an aldehyde, where you'd want to separate that off first, because the aldehyde will easily get oxidized further, and an aldehyde has a lower boiling point. And the other, and just the same, if you oxidize that to a carboxylic acid from, say, a primary alcohol, you may want to increase the rate of reaction to ensure you get maximum product, if that was what you wanted. And in that case, you'd use reflux. There's a third reaction that often gets asked, and that's an acid chloride one, where you're doing a substitution reaction. And that's similar to this, where you do reflux initially to form your product, but there's a mixture in there, so you separate it out based on distillation, on boiling point rather, with distillation.